All right, so in this video, we are going to practice factoring. So we're going to review the slip and slide method that we did last time. Then we're going to review difference of squares, the difference of squares. Then I'm going to teach you how to do the sum or difference of cubes. And then we're going to learn how to factor by grouping. Here we go. If you're in my class, then we are going to use the bottom of this page. So go to your notes from November 14th. We had Module 4, Lesson 4 practice. We're going to go towards the bottom of that. And we're going to do Module 4, Lesson 4, more practice with today's date, which is 11/18/25. The problem we're going to practice with is, what if we had 6x cubed plus 26x squared minus 20x, and the direction said to factor that? All right, so if you go back a page and look at your notes, part 1 says, or the first step is to put it in standard form. This one is already in standard form because it has its highest exponent first, the x cubed, then goes down to x squared, then to x. I'm sorry for the focusing. It has been so weird today. Let's give it a line to focus on. So then the next step, step 2, right? We drew that very fun face yesterday. And so it says to say, hey, can I take out a greatest common factor? All right, so our greatest common factor here is going to be, let's see. Ooh, I can do a 2 because that'll be 3, and then that'll be 13. 3 and 13 don't go together, so I can't do more than a 2, but the 2 will work there. So I can take out a 2. And then I check the variables. Can I take out any variables? And yes, I have an x that is common to each of them. And then I have to put the leftovers back inside. And how do I find out what the leftovers are? Well, we divide. We divide by the 2x to each term that we took it out of. And so then we get 6 divided by 2 is 3. X to the third divided by x. We subtract exponents when we're dividing the same base. So 3 minus 1 is 2, so we get x squared. 26 divided by 2 is 13, so we get plus 13. X squared divided by x is x. 20 divided by 2 is 10. X divided by x is 1. All right. Once you've done that, step 3 is to find A, B, and C. I suggest that you pause the video, see if you can find them without me. So then A is 3, B is plus 13, and C is negative 10. Notice that we're taking the A, B, and C from our new trinomial that already has the 2x factored out, right? Then our next step says to check our A. If A is equal to 1, then we just use x factor like we've done a million times on our worksheet. But x is in fact equal to 3. So then we have to use our special x factor where we slip and slide. I really encourage you to write the word slip and slide to hopefully help you to remember to do both parts. So we slip that A times C, which is 3 times negative 10, or negative 30 on the top. And then B goes on the bottom. What goes on the bottom? B. So we have 13 at the bottom. Step 5 says to list your factors. So I'm going to write the word list to remind myself. And I start with 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Now I'm looking for something that will add or subtract to make 13. Well, I love 3 times 10 because 3 times 10 adds to make 13. But I cannot get it to multiply to make a negative 30. So 3 and 10 cannot be the factors I need. So it will in fact be a 2 and a 15, where the 15 is positive, so I end up with a positive 13, and the 2 is negative. And that'll give me x minus 2, x plus 15. Now be careful, this is why we wrote the word slide, so that we can remember that now we need to slide our a underneath each of those. What was a? We have it right here. A is 3, so I divide by 3. 2 divided by 3, does it go evenly? It does not. Can I reduce? Like, could I divide by 2 over 2 or 3 over 3? I also cannot. So this 3 is going to move up right next to my variable. So we get 3x minus 2. It slides in next to the exponent, next to the variable. Now 15 divided by 3 divides nicely. That'll give us 5. So this binomial will be x plus 5. Then you just have to remember this 2x that we took out way back in the beginning. And that's your answer. Nice job. Now go ahead and turn to your next blank page. And we're going to title this one, Module 4, Lesson 4, Difference of Squares. I say it's silly to try to help you remember to look for them, because remember, these are our specials. These are our specials that we have to look for when we're done, when we think we're done factoring, okay? This one you learned in Algebra 1, and then we practiced it a little bit, and I think Module 2. So let's just do a couple of them. First, please note that these have to be subtraction. All right, so it has to be subtraction. So an example would be 4x squared minus 25. So when you look at 4x squared minus 25, you're like, oh, cool. It's already in standard form. You say, hey, can I take out a common factor? I cannot, because 4 and 25 do not share any common factors. I can't take out a variable. There's no x. So you think you're done. But then we have to look for our specials, right? So looking for your specials, this is one of our specials. So you need to notice that 4 is a perfect square, x squared is a perfect square, and 25 is a perfect square. So then you set up your factoring parentheses ready for your binomials. And we just do, what is the square root of 4x squared? Well, that would be 2x. So that becomes the first term in each of our binomials. Then what is the square root of 25? 5. But the correct answer is plus or minus 25, right? So then we end up with plus 5 or minus 5. And again, look for your specials. We don't have anything squared, so it cannot be a difference of squares. Nothing's cubed, so it cannot be a sum or difference of cubes. So we're good. I would like you to put something over here just as a little side note, because sometimes this will throw you off. But side note, 4x squared plus 25 cannot be factored. It's finished. So what's the difference between this one and this one? Why can this one be factored into 2 more binomials, but this one is finished? Because the one on the left is difference of squares. The one on the right is adding, so it is finished. Let's do another. What if we have 36x squared minus 49? We start by putting it in standard form. Boom, it already is. Next, we see if we can, take anything out, right? A greatest common factor. 36 and 49 have nothing in common. There's no variable on the 49, so we can't take out a variable. But then you have to notice, you have to look for your specials and notice that it is a difference of squares. So difference of squares, we're going to end up with two binomials. One will be a plus, one will be a minus. What is the square root of 36x squared? 6x. So that'll be our first term in each binomial. And then what is the square root of 49? Square root of 49 is plus 7 or minus 7. Done. Same pattern every time. So next problem, let's try 25x squared minus 16. I suggest that you pause here and see if you can do it without me. Our answer is going to be two binomials. And then we just take the square root of 25x squared is 5x. That is our first term in each binomial. Square root of 16 is going to be plus 4 or minus 4. If you did it by yourself and you got the answer 5x minus 4 times the quantity 5x plus 4, whose answer is more correct? Neither one. They are exactly the same. They're both equally right. All right. Well, let's just do one more. The last one for practicing difference of squares is a little different, because sometimes when you're working on a more difficult problem, you'll factor it out and it'll look like this. And you'll be like, cool, I'm done. This is gorgeous. But you really have to notice that this one is the difference of squares. And because it's difference of squares, we have to keep going with our factoring. So a difference of squares is going to give us two binomials, right? The square root of x squared is x, so that'll be the first term in each one. And then the square root of 1 is plus or minus 1. So plus 1 minus 1. And then you cannot lose or forget this binomial that has to continue down into the answer. And so these three binomials end up being your answer. Nice job. Pause if you need to check anything. I'm going to a new page. So our new page is going to be to find the sum or difference of perfect cubes. So let's go, module 4, lesson 4. Sum or difference of cubes. Today's date, 11/18/25. Let's start with this is our problem. 27x cubed minus 64. So when you look at that, you're thinking the coefficients don't have a greatest common factor. The variable doesn't have a greatest common factor. So we're done. Except that when we're looking for our specials, right? Look for those specials. There's not a perfect square. However, there is a perfect cube. So you have to look over at your perfect cubes list to check and see if any of those will work. And sure enough, we have 27, so perfect cube of 3, and 64. 4 cubed is 64. So there are a couple of ways to do it. I'm going to do it two different ways. So I'll start with one, which would be you can just take the cube root of this, just like we took the cube root of the other, and you can take the cube root of this, and then go through and work out your problem. However, I find it more helpful to write it with the perfect cubes instead. So I'm going to do that. I'm going to go 3 cubed x cubed minus 4 cubed. So I have the 27 as a cube, the x is a cube, and the 4 is a cube. And then you have to follow the pattern. So these are going to end up being a binomial times a trinomial. In the binomial, we put all of this, but without the cubes. So it'll be 3x minus 4. Then this is going to have 3 terms. So the first term is going to be this term squared. So 3x squared is 9x squared. I am going to draw a little line to show you what happened there. We went 3x squared to get that term. Okay. Now we had a negative here, and so we have a negative here. And we're going to write an S under there to say that this is going to be the same sign. I'm going to keep that same sign. But here, we're going to have the opposite sign. So we had a negative, now we're going to have a positive. And to get this middle term, we multiply the 3x times 4. 3x times 4 is 12x. And then at the end, we have an AP, which means always positive. So this last term, we're always adding. And it's going to be 4 squared, which is 16. And so let's also draw a little line here. 4 squared is where we got the 16. Okay. And so that spells SOAP at the bottom to help us remember our terms. So let's write what SOAP stands for at each section. So under the S, I'm going to write same sign. Under the O, I'm going to write opposite sign. Under the plus, I'm going to write always positive. And that's how SOAP is going to help us with our perfect sums or differences of perfect cubes. We'll do a couple more together and I'll try to help you look for things, but we should look and see if anything here can be factored. This cannot because there's no square on it, nothing can come out. Maybe this could work if we put it into the quadratic formula, but we do not need to. But it does not factor easily. It does not factor with slip and slide, so we don't need to check further. All right. Well, let's do another one. What if we had 8x cubed minus 343? I know, you're thinking this is great, 343. There's no way there's anything special about it. We can be done. Maybe we should just check, just in case, right? So you're going to go to your perfect squares and we're looking for 8 and 343. There's 8. Boom, there's 343. 7 cubed is 343. So here we go. So I'm going to rewrite it as cubes, right? So 2 cubed x cubed minus 7 cubed. And then the pattern is that I'm going to have a binomial times a trinomial. So here we start with just 2x minus 7. Right, I use the same sign. Then to get this, I'm going to have to go 2x, that whole thing squared. 2 times 2 is 4. X times x is x to the 4, sorry, is x squared. Another way to think about how you're getting this 4x squared is if you think our 8x cubed is really 2 times 2 times 2 times x times x times x, right? 3 2's, 3 x's, all multiplied together. Then you divide that by the 2x that I'm taking out here. Well, that cancels, that cancels, that cancels, that cancels. I'm left with 2 times 2, which is 4, and x times x, which is x squared. All right. Now our O tells me I'm going to have an opposite sign here. So instead of a negative, I'm going to have a plus sign. Here I multiply 2x times 7, 14x. My AP of my SOAP tells me this is always positive. And it is going to be 7 squared, which is 49. And you are finished because there's no special here. This you would have to use the quadratic formula for. And so we can be done. Let's do another. Let's start with 216x cubed minus 125. I encourage you to stop here, pause it, and see if you can do it without me. Like the only way to find out if you can do them is to try them. All right. I would look at my chart. I'm looking for 216 and 125. There's 125 is 5 cubed and 6 cubed is 216. So then I'd write them as cubes. So this is 6 cubed x cubed minus 5 cubed. When I factor it, it's going to give me a binomial and a trinomial. I start with 6x minus 5 because that's right, everything without cubes. Then I write the leftovers, which is going to be 6x times 6x, which is 36x squared. You're going to have the opposite sign, so plus. Then 6x times 5 is 30x. The last sign is always positive, and it's going to be 5 squared, which is 25. Let's try one that's positive, that's adding from the beginning, because everything I've done so far is subtraction. But this one works with the sum or difference of cubes. Difference of squares, only subtraction. Difference of cubes, I mean, like it's sum or difference of cubes, so it can be either one. So let's try 64x cubed plus 27. So we're going to start by doing the perfect cubes. Let's go see what they are. We've got 64 and 27. 64 is 4, 27 is 3. So I have 4 cubed x cubed plus 3 cubed. My factoring is going to give me a binomial and a trinomial. The binomial gets 4x plus 3. And so this is the only place that it changes between a difference or a sum, is that our SOAP, we just have to be careful of it. SOAP, so I'm keeping my same plus sign. Then I do 4x squared, which will be 16x squared. Now I do the opposite sign, so now I'm going to get a negative sign. And I multiply 4x times 3, 12x. Last sign is always positive. And I do 3 times 3, or 3 squared, which is 9. If it helps you to put the, oh, I got this because I did 4x times 4x, then put those arrows in for yourselves, right? If it helps you to know that we got 3 times 3 to make it 9, write those in. This one I didn't write, but it's going to be 4x times 3. The 4x times the 3 will give us that center term. All right, last one. And this one's super important because it's the kind that you will find as a partial answer when you've done a whole bunch of other work. So know that even if this were in parentheses and you had other binomials or trinomials next to it, this is not done factory. Like, this is what we're talking about when we say, look for specials. 1 is a perfect square and a perfect cube and a perfect fourth power. Like, it's perfect in every way, right? Okay, so this is a difference of cubes. So I'm going to end up with a binomial and a trinomial. I mean, I didn't write it down this time, but it would be x cubed minus 1 cubed. So we've got x minus 1 here. And when we bring it over, it's going to be x squared. Ooh, what is my, so same, opposite. So now it's going to be plus x times 1 is 1x. Always positive here. And then 1 squared is 1. All right, pause here if you need to look at anything, and we're going to go on. Our last page. Module 4, lesson 4. Factoring by grouping. 11, 18, 25. Something that would be nice if it stood out to you is that we use when you have 4 terms. Guess I've overused the red pen today. It's running out. All right. All right, so let's look at what if we had 2x to the 4th plus x to the 3rd plus 16x plus 8. So we're looking at it and we're thinking, okay, ooh, maybe I could take out a 2. Oh, there's not a coefficient there, so I can't take out a 2. Ooh, maybe I can take out an x. There's no x there, so I can't take out an x. And then there's too many terms for it to be a perfect anything, right? So where can we go from there? So we can separate it and just do half the problem and then do the other half the problem. So it's called factor by grouping. I'm going to group them right there. As you get good at it, you might have a problem where you actually have to rearrange them, maybe take them out of standard form to make it work. But I don't think we're going to do that to you this week. So you should be okay. So now just looking at that group, at that half of the problem. Hey, can I take out a greatest common factor? And the answer is yes, I can take out an x cubed. So I'm going to take out x cubed. And then I have to find out what my leftovers are. I do that by dividing by x cubed. And we end up with 2x, because when we're dividing exponents with the same base, we subtract. 4 minus 3 is 1. So we get 2x plus 1. X to the 3rd divided by x to the 3rd is just 1. And now we do it to this side. So we look at this side and you're thinking, okay, 16x plus 8, I can take out a 2, right? Because they're both even. I cannot take out an x. Can I take out more than a 2? Yes, we could take out a 4 because 4 goes into 16 and goes into 8. If you do that, you will have to do another step because we can actually take out an 8. So this is where it's handy to know your times tables. You can also use a times table chart to try to find 8 and 16 down the same column. And so if I take out 8, I have plus 8. And we divide by 8 so we can see what we have left over. 16 divided by 8 is 2. Don't forget the x. 8 divided by 8 is 1. Really important that you notice these two are the same. If what's in your parentheses on each side of the group is not the same, then you have to go and find something else. It won't work. Those two binomials have to be the same. Because then the next step is that our answer is going to be x to the third plus 8 times the quantity 2x plus 1. Now, we've done this before where we started like this, and to multiply them, we put this outside and that outside, and we wrote the 2x plus 1 twice. So we're just doing that backwards. And then, of course, as always, we need to look for specials. So are there any specials in that answer? There is. There's not a difference of squares because this isn't squared, but we do have perfect cubes. So let's continue from there. So we end up with x cubed plus 2 cubed, right? And then we have 2x plus 1. We can't lose that part. The sum of cubes is going to factor into a binomial and a trinomial, and then you cannot lose your 2x plus 1. And then you might have to go back a page and look at the pattern, but the pattern is going to show us that we get x plus 2. The first term here is going to be x squared. So I have the same, now I have the opposite sign. So it's going to be minus x times 2, which is 2x. The end of my slope is that it's always positive, and we get 2 squared. 2 times 2 is 4. And so that is your final answer. The quantity x plus 2, let me see if that'll help it focus. The quantity x plus 2 times the quantity x squared minus 2x plus 4 times the quantity 2x plus 1. Nice job. So just a heads up, I worry because if you get this answer on a test with me, I'll give you partial credit, right? Like you did a bunch of work. You got partway through the problem. That was lovely. But then to get full credit, you have to look for those specials, find the special, know how to factor the special, and write the complete answer. But on a state test, on a college placement exam, on the SAT, PSAT, I don't know if those are going to look hard enough to give you partial credit. Like they may really want to know if you can look for the specials, find them, and factor them. Let's do one more. What if we add 2x to the fourth plus 3x to the third minus 2x minus 3? So again, put it in standard form. It is in standard form. Yay! See if we have any anything. Hey, can we take out a greatest common factor? We cannot because we've got 2's and 3's, and then there's no variable on the constant. So we've got 4 terms, so we're going to try to factor by grouping. So I'm going to separate it down the middle again. Looking at that first half, is there anything I can take out? Sure, I can take out an x cubed again. And that's going to leave me, let me write it down so I can see it better. Divided by x to the third, I'll get 2x. Divided by x to the third, I'll get plus 3. There we go. And then I do it to the other side. Oh, it's almost already there. I have 2x plus 3, and then on the other side, I have 2x minus 3. So to get them to match, I'm going to take out a -1. So when I divide this by -1, divide that by -1, -2x divided by -1 is going to be positive 2x. -3 divided by -1 is going to be plus 3. Now these are matchy-matchy. Yay! And so then I can group it together. I've got x cubed minus 1 and 2x plus 3. Yay, beautiful. Make sure you look for your specials. Do we have anything special in there? We do. X cubed minus 1 are perfect cubes. So we have x to the third minus 1 to the third. So we have to factor that. It's going to give us a binomial, a trinomial, and then you cannot lose your 2x plus 3. The first binomial will end up being x minus 1. Then you get x squared. Oh, use your soap. Same sign, opposite sign. So now I'm adding. X times 1 is 1x. And then always positive for our last term. 1 squared is 1. And then that is your finished product. Have a great day.